Welcome everybody to a new video. In this video I'll explain you the first and the second Kirchhoff principles. Before I begin I would like to tell you that if you like my videos you could consider the idea to give me a like or subscribe to my channel. It is just a little effort for you, but it will be very helpful for me. Okay, let's begin. So, let's start with the first Kirchhoff principles. I'll explain you with an example, because in my opinion it is more simple to understand it with a practical example. Let's imagine I have an electric mesh, very simple electric mesh, made like this. Just one voltage generator and two resistors, okay? Here I have a voltage generator and here I have R1 and R2. So now let's imagine what will happen here, what will happen. Well, I will have a current in this mesh, and the current will flow in this direction because the voltage generator is positioned in this direction, so the current will flow like this, okay? I will have a current in this mesh and also I will have two voltage drop, okay? One voltage drop here, VR2, and another voltage drop here, VR1. If you don't remember how the voltage drop works, I have another video in my playlist, you can just check it and you will understand how the voltage drop works. But okay, let's go back here. So I will have two voltage drop, one here and one here. As I already explained in other videos, if I add this voltage drop with this voltage drop, so if I do VR2 plus VR1, I will obtain the same value as the voltage generator. VR1 plus VR2, they will give me the same value as the voltage generator, okay? Well, the first Kirchhoff principle says exactly this, just it says it in a different way, just in my opinion in a more complicated way. In this way it's more simple, but basically this is what the first Kirchhoff principle says, but now we'll explain it in the official way, in the way that how it is usually explained, okay? The first Kirchhoff principle says that I'll write it. Well, the algebraic sum of all the voltages in a mesh is always zero. This is what the first Kirchhoff principle says. Sometimes said in this way, it could result like a little complicated to understand for people who are starting to study these subjects. Maybe if you're starting to study these subjects and someone says the first Kirchhoff principles like this, it may result like a bit complicated, okay? It may seem like it is a bit complicated, but in reality it is not. It is very simple. Just remember this. If you add all the voltage drops, you will have the same value as the voltage generator. Now let's concentrate a bit on this picture. As you can see, the voltage generator and the voltage drops are positioned in opposite direction. The voltage drops are oriented in this direction, you can see, okay? And the voltage generator is positioned in this other direction. So the voltage generator and the voltage drops have opposite directions, okay? Here where there is the arrow direction, there is the plus of the voltage drops, okay? So the total amount of voltage drops, this plus this, and the voltage generator, okay, so the total voltage drops and the voltage generator are like two equal forces who create this equilibrium of zero, two equal forces in opposite directions, okay? The result is zero. And this is what the first Kirchhoff principle says. So now let's go back to the picture and let's learn how to write the Kirchhoff equation, okay? So to write the Kirchhoff equation, you have to keep in mind, you have to look at the current direction, okay? So looking at the current direction is fundamental to write the Kirchhoff equation. So let's look at the current direction. What is the current direction? The direction flows in this way, in this direction. The direction, sorry. The current flows in this direction. Okay, so current flows in this direction. Now, if I want to write the Kirchhoff equation, I have to understand this. So this is a voltage, this is another voltage, and this is another voltage. I have to look at all the voltages in the mesh. So look at all the voltages in the mesh one by one, and the voltages which are oriented in the same direction as the current, they are considered positive. Okay, so this voltage is oriented in the same direction as the current. The current direction is this, and this voltage orientation is this. So it's the same orientation as the current. Okay, so this voltage is oriented in the same direction as the current, and it will be positive in the Kirchhoff equation. I'll write this. Then I encounter this other voltage, and this voltage is positioned in the opposite direction of the current, so it counts as negative. Then I encounter this other voltage, and this voltage is positioned in the opposite direction of the current. Current flows this way, and this voltage drop is positioned in this way, so this counts as negative. Sorry, yes, there is VR1 minus VR2. And this equation is equal to 0. E, okay, so the voltage generator minus VR1 minus VR2 is equal to 0. Okay, this is the Kirchhoff equation of this mesh, this way. I can also write it in this way, it's the same, but usually you write it this way, okay. So we have understood, I hope you have understood at least, how to write the Kirchhoff equation of a simple mesh like this. Now we could prove it with an exercise, but before we prove it with a practical exercise, I would like to explain you the second Kirchhoff principle. Okay. So this was the first Kirchhoff principle. Let's explain the second Kirchhoff principle. So the second Kirchhoff principle says that, let's imagine you have an electric node here. This is a node, let's call it N is a node, okay? Or let's call it A, I don't know. This is the node A, just to give it a name, okay? And I have like two cables, okay? I have two cables going in this node, and then I have three cables coming out from this node. Okay. In each cable there is a current. Okay. So I have these two currents going here in this node and three currents coming out from this node. I3, I4 and I5. Okay, the second Kirchhoff principle just says that the sum of all the currents coming in a node is equal to the sum of all the currents coming out from this node, from this same node. Okay, so remember this. The sum of all the currents going in a node is equal to the sum of all the currents coming out from this same node. Okay, I'll write it. Okay. This is the second Kirchhoff principle. I'll repeat one last time. Okay. So the sum of all the currents going in a node is equal to the sum of all the currents coming out from this same node. Let's write it. In this case, I1 and I2, they go in. And I3, I4, and I5, they go out from this node. So I1 plus I2 is equal to, guess what? I1 plus I2 is equal to I3 plus I4 plus I5. Okay, this is the second Kirchhoff principle. We could also explain it in a different way, and I'll just make you this very short example, and then for this video is enough. So let's imagine the opposite situation. I have one single current, I, and the single current will divide into three current, I1, I2, and I3. Okay, because very often I will find this situation instead of the other situation I have just now explained. Very often I will find this situation. So in this case, what happens here? This I divides into three smaller parts. But if I make I1 plus I2 plus I3, I will obtain still I, the original I. And then these three currents will unite again here. And here I will have still the same I as before, the same current as before. Okay, very often you will find this situation. It is more, I don't know, you will find it way more often, this one. But this is still the second Kirchhoff principle, just pictured in another way, in a different way. Let's imagine the node here. There is a node here. Okay, this is the node A. And what happens here? From this node where it enters, and I1, I2, and I3, they come out from this node. Okay, so I is equal, in this case, the sum of the current and who enter in this node is just I, and the sum of the current who come out from this node is I1 plus I2 plus I3. 1, 2, and 3. Okay. In this other case, this is the node B, okay? Well, in the node B, it happens the opposite. I1, I2, and I3, they enter inside here, and what came out is I. So I1 plus I2 plus I3 is equal, okay, is equal to I. I1 plus I2 plus I3 is equal to I. So this is what happened in node A and node B. This is another different way to understand the Kirchhoff principles, but we are still talking about the same thing. It is still, this one is still the second Kirchhoff principle, just pictured in a different way. It is just that here the current who enter inside is 1, and the current who come out from the node, they are 3. Here the current who go inside the node are 3, and the current who came out is 1. Okay, and since this current, okay, come here and divide in two parts, this current arrives here and it divides in three smaller parts. Since these three smaller parts will reunite again here, the result will still be the same current I, which was entering here. Okay. Okay, I think for this video is enough. I hope you have understood the first and the second Kirchhoff principle. We'll do some demonstration, some very simple exercise in the next videos. Okay, for this video I think it's enough. I don't want to make it too much long. Okay, So let's stop here. If you have any questions, you could ask me in the comments. I do everything possible to answer you. Don't worry. I understand English pretty good actually. Just I can read it very well. I can answer you. No problem with this. Just when I talk, I'm a bit, I'm not perfect when I talk. My English is not perfect. But don't worry, I understand if you write. I understand everything. Even if you talk to me, I understand everything. It's just when I speak, I'm a bit. But if you have any question, write them and I'll answer you. For this video is enough. So let's see in the next video. See you in the next video. Bye.